Hi, I'm Will Cavendish, Arup's Global Digital Services Leader, and I'm delighted to welcome you to this Fireside Chat. Following the launch of our survey, Embracing AI, Reshaping Today's Cities in Built Environment early this year, we're opening up a series of conversations with global leaders and organizations who are shaping how AI will transform the built world. Today, I've got the fantastic pleasure of speaking with Sean Young, who's the Director for AECO Geospatial and AI Solutions Industry Marketing from NVIDIA, a company at the forefront of AI innovation. Together, we'll explore why AI is fast becoming essential for tackling the challenges of climate resilience, infrastructure delivery, and urban growth, and how tools like generative AI, Omniverse, and digital twins are already enabling profound change across the AEC sector. So, very warm welcome, Sean. Sean, you're somebody who's passionate about AI, and you've got a long and distinguished career of developing AI and working in AI. Why do you feel developing AI is such an imperative for those of us who work in the built environment?
Yeah, well, the reason why I'm passionate about it is because I work at NVIDIA, where we get a firsthand look at the most innovative things happening on our planet in the realm of AI. And I see the transformation that AI is having on other industries, and it's quite remarkable. So I can imagine that same transformation happening in AEC. And I look back at the evolution of technology in AEC from, stone tablets to blueprints to 2D CAD to 3D to BIM. And I don't know that there's necessarily been this exponential improvement in productivity. I think we're still very much in a manual process. If anything, all of this technology has created additional complexity, particularly like when you get down to the construction site and you're unable to identify the source of truth with all these different file formats. It's a bit of a mess. So I'm really excited about the opportunity for AI and specifically, I think agentic AI, to bring that sort of exponential improvement in productivity that we're seeing in other industries. And I'm starting to see it in AEC. I met with a construction company this week who has developed their own AI models for the estimating process, and they're looking at savings of approximately $500 million a year, which is quite extraordinary. So I think we're on the cusp of something here, and it's really important that we pay attention.
Yeah, brilliant. So the sort of flip side of the poor productivity record, the disorganized industry, and the slow pace of digitization to date, I guess the flip side of that is that the opportunity for improvement is very, very large, as you say. So you can get some very, very big benefits coming for some sort of relatively straightforward actions. So to what degree do you feel that's a little bit about just getting the sort of fundamentals right, even before you bring in AI to the table? Or to what degree do you think that AI is going to be absolutely central to all of this?
Well, I think, going to first principles, I think we need to understand AI and what it can do for the industry.
Yeah, really, really interesting. I mean, I think what our experience has been to date is that so far, the various different AI models that we've been deploying have been augmenting rather than replacing human intelligence. So, I mean, I think you probably know a little bit of this, but we've been using AI to help us design city infrastructure better, both more quickly and with lower carbon and lower cost, or speeding up the process of sort of building design by using generative design to get to massive optionality much earlier than would be the case. A range of other use cases as well. But I think what we're finding so far is that AI capabilities are helping improve our engineering intelligence and our technical expertise rather than replace it. And I wonder whether that's a pattern you're seeing in AEC at all, or are you seeing sort of other things happening around skills replacement?
Yeah, there may be a time when AI automates things to the degree where it's replacing humans, but I think we still have a ways to go. I've got two kids in engineering in university, and we have this conversation all the time. My wife's very concerned, like they're working so hard. Are they going to have a job? Are
Well,
they
I
going
have
to
a
be
job to
replaced
go
by?
to. Love it.
Exactly. So, I tell them what I tell everybody, and what NVIDIA says is that it's likely in the near term that people, including engineers, who know AI are going to replace those who don't or who are unwilling to learn. But it's unlikely that AI is going to replace anybody yet in terms of the total number of jobs, because our industry really, really, really needs humans who understand what to do with this technology and how to implement it, because the technology is not going to figure that out on its own. We need to define the use cases and put the technology to work in the right way.
Yeah. So this sort of human plus artificial intelligence being greater than either on their own, I think is something that's sort of coming through quite powerfully. Sean, can I ask you a bit? In Arup, we've been sort of deploying AI in all phases of what you might think of as sort of classic built environment processes, from sort of planning stuff through to designing it, through to constructing it, through to operating it, maintaining it, replenishing it, decarbonizing it. Do you feel that AI is going to be equally beneficial in all of these different areas, or I mean, do you see areas of particular productivity improvement or particular innovation breakthroughs in different aspects of the built environment, or do you think there's just so much to go at that there's sort of AI everywhere, really?
I think it's AI everywhere, really. Like I have this analogy in my head, which is you get back from vacation and you've got a dried up plant. That's AEC. It's desperate for water, and you pour the water in. The water is AI, and the water goes everywhere because there are so many error-prone processes. And where there's error-prone processes, there's probably manual processes, and humans can miss things, especially when we're dealing with all these different vendors and partners in the AEC environment. There's tons of collaboration, lots of room for broken telephone, lots, as we discussed, lots of different file formats and blah, blah, blah. Things get lost in translation. I think AI across the board, from design, engineering, construction, operations, has room to raise the bar.
It's really interesting what you say, Sean. I mean, we're working on sort of major construction projects, and you can find sort of 500,000 documents are generated by, a single major infrastructure project. And at a certain point, nobody knows what they are, where they're stored, what they contain. And the result of that is all of the time and the delays and the misinstructions and the problems get accumulated, just as you're describing. So just scripting a sort of reasonably decent large language model that allows you to access all of that information can bring huge productivity benefit. And I guess another bit we've seen a lot of is building energy. So many buildings heat and cool the same bit of the building at the same time. It's like opening the window and throwing money out the window. You might, so the opportunity of making significant improvement, I think, is really high, which I think we're seeing across the piece. Sean, I wanted to just ask a slightly sort of different question, particularly around sort of Gen AI and large language models. I think our experience in working with those is that many of them sort of lack the physics and the geometry and the science to make them fully usable in the in the world of the built environment. So, for example, lots of large language models don't have any spatial recognition in them, or any spatial, even geospatial tagging, which doesn't make them so useful. NVIDIA, I think, for me, stands out as a company that's been really developing the sort of the physical aspect of AI with things like Physics Nemo, with Omniverse, and has taken very seriously that development of those capabilities. Just be great to hear a bit more about what led NVIDIA to kind of really push forward in that direction, and maybe a chance to plug a bit what some of the benefits are that people are seeing from working with NVIDIA.
Yeah, well, in terms of, I mean, there's a lot of legacy in terms of our thinking about physics. I mean, we're a physics-oriented science company, and everything we do is challenging the laws of physics in terms of the compute we can deliver and the conversion of energy to compute. We're always thinking about physics in terms of our own technology. Now that we're working with partners and customers to build out the largest data centers our world has ever seen, the biggest problem we have is actually the conversion of power to compute, because we've got a limited supply of energy. So we have to be really thoughtful in the way we design, engineer, build these data centers, including MEP, which is at the heart of it, and water cooling and electrical, et cetera, so that we're efficient. We're at NVIDIA, we are pushing the limit on what's physically possible in the chips and the infrastructure and the compute hardware. We have to extend that out to the entire ecosystem. And because of that, I mean, we're thinking about, the physical ways that design can be improved with AI. But it's not only limited to data center. We have physics-based solutions, for example, with computational fluid dynamics, as you mentioned, Physics Nemo. But our legacy or our heritage goes back to tackling those problems from a compute perspective before AI, with HPC solvers and parallel computing supercomputer type of environment. So physics has always been something from a healthcare, from an engineering and from science, weather prediction. It's always something we're thinking about, and we work very closely with the science communities on those problems.
Yeah, brilliant, brilliant. So there's a sort of deep rooting of that in NVIDIA as a company, plus an element of dog fooding some of the things yourself, but then becoming really useful capabilities for those of us who work outside NVIDIA in the world of the built environment. We're certainly, as Arup, we're finding the physics-informed neural networks, physics-based neural networks, graph neural networks, all of those being the sorts of things that are the most exciting ones, I think, for tackling really fundamental problems. And NVIDIA's, the worlds that you've been creating, the capabilities, I think we're finding quite exciting. Are you finding sort of others flocking to you in this kind of area?
Yeah, well, what's really interesting is our supply chain. You mentioned eating our own dog food. So we're working super closely with our supply chain, like TSMC, and for the chip fabs and the chip design process, Foxconn for the factories, and also engineering and construction companies who are building our data centers, to improve and optimize the process with AI. And that's really because there's such a huge demand on our products and technologies, we really want to optimize our supply chain, make our vendors more efficient, and they see the value. And a lot of this stuff is cutting edge. And we have, from a customer perspective, we are the customer. So we have very unique insight into elements that can be improved. And again, it's all about physics. You mentioned Omniverse. Our digital twins are being used by TSMC, Foxconn, and other manufacturing partners to optimize their production lines, plan new factories, et cetera. And again, at the core to all of this is physics, because we're looking for KPIs on how the elements of the factory that move around, that can be refined and redesigned and work together, can be optimized. And a lot of this, interestingly, applies to the construction site, because if you take a factory, you have lots of things that move around, you have mechanical things, and you have people, and you have a progression over time. You take those same elements out to the construction site, and the same problems. We even have a toolkit called QOpt, which is AI for optimizing and solvers for optimizing the logistics flow. It's like the traveling salesperson problem, and it's used by the carriers like UPS, et cetera, but also used for fleets of robots, and can also be helpful, for example, in planning construction in terms of parts and subcontractors coordinating on site.
Brilliant. Brilliant. So, I mean, so much fascinating stuff, and so much developing. So the next question, or my final question, is sort of, it always seems too much to ask, but where do you see this all heading? What do you think the next kind of 2 or 3 years look like in both the development and deployment of AI in the built environment? What is the crystal ball telling you?
Well, I think we're at a super interesting time, Will, especially because it's a very different time than the last major disruption to this industry. What do you think that would be? BIM? Do you think that was the last major disruption?
Technology
or was
disruption,
it CAD?
I guess. Yeah, something like
yeah.
yeah.
So, BIM came around, or even CAD. Well, let's even go back to AutoCAD. When Arup and everybody else started working on AutoCAD, you weren't really working on computers before that. So everything that came to you was like off the shelf, and you didn't really have, the people in the company didn't really have the knowledge and the experience to have an influence on that process. The software came from software companies. The hardware came, as it was from hardware companies. Now we're in a completely different place because we're much more sophisticated. You at Arup are incredibly sophisticated. You're building your own software. And you have talented people who understand data science and software development and AEC customer use cases and so on and so forth. You are like, in effect, masters of your own domain. And now you have a choice. Do you want to use ISV applications from the large ISV companies? Do you want to build your own AI tools? Or there's this incredible array of startups. I've never seen anything like it. And it's so wild that there's now VC companies popping up. I'm sure you know about it. NVIDIA's to help. We're creating a list of AI startups in AEC in partnership with the HP and AEC magazine. So this is like an announcement to the world, a sneak peek. It's coming up soon. So, I mean, at Arup, you've got so many options to build the best possible outcome at the lowest cost and the most efficient way. To me, that's, tremendously exciting. But I think, last thought, and you probably have been thinking a lot about this, is AI is only really really useful to Arup if it understands the way you do things, and that's your data, and if it's fine-tuned or trained on your data. What do you think about that?
I think that's absolutely right. I mean, we have the dreams of trying to encapsulate everything that we've done in 70 years in a large model. I think that's going to be a bit of a fantasy rather than a dream. But it gets to the point that a lot of the the current large language models or large models are likely to become commoditized. My strong belief is that the real value will come from specialized AI that brings together deep technical engineering expertise with the data capabilities and the AI capabilities that provides amazing insight and new ways of working. And that's unlikely to be sort of general purpose models. It's much more likely to be bespoke capabilities built on general purpose models. So this combination, as you're describing, of engineering, physics, real world use cases, and the experience of knowing what the client's problems really are, you wrap that together, and that is extremely powerful and very exciting, I think.
Yeah, and then there's this promise of all these best of breed AI models and tools that you're talking about kind of working together autonomously or semi-autonomously as agentic AI, which to me is really exciting. And that's when I think you start eliminating those errors and really improving productivity, because you don't have to have a human in the loop 24/7.
Yeah, sure. One final question for me. What you were just talking about a company like Arup being able to pick and choose from different models, different providers, different partners, and so on is true. But at the same time, often the development of genuine expertise needs strong, long-time collaborations between different players within an industry. And that's certainly what I think we in Arup now feel, that we need to develop really long, deep relationships with the likes of NVIDIA and others if we're going to fully unlock the power of this technology. I just wondered what you thought about how collaboration or partnership may change the historic models that we've developed in the built environment.
Yeah, I think to us the path of least friction is around standards, because if all industries agree to invest in standards, then we reduce the friction for our customers. Then the customers get the choice of whatever tools they want to use. as long as those tools are based on standards, they're interoperable and interchangeable. In terms of partnership, yeah, I completely agree. NVIDIA is a partner-centric company. We don't sell directly to customers. What we'd rather do, and you've probably heard me say this multiple times in this chat, is we want to empower our partners with our technology. We make the low-level core pieces of technology for software developers to use to build up their tools. And many software developers, as you know, are doing that, are using NVIDIA technologies, and that, like CUDA, and that helps also with building this ecosystem and community of technology that works together on the same infrastructure. And anything that runs on CUDA, NVIDIA CUDA, runs on the laptop, the desktop, the data center, the cloud, any NVIDIA GPU anywhere. So that's and in terms of partnership with Arup, I mean, we embrace that very strongly. So I think there's a lot of exciting things we can do together.
Delighted to hear that, Sean. Well, I'd agree with everything that you said, apart from your description of NVIDIA's work as low level. I'm not sure. I would describe it as pretty cool and pretty advanced. Look, Sean, that's all we've got time for. I really appreciate you having the conversation. As I said, you're somebody who's passionate about this. You've been working on it for a while. You're deeply knowledgeable, and you're a visionary in thinking about what the industry looks like and the challenges it faces. So really appreciate your time having this chat together. And we'll look out for that list of startups that you mentioned that's going to be coming. It's breaking news on this chat together. But much appreciated the conversation, Sean. Look forward to having more in the future. And thanks for joining today.
Thank you so much, Wal. This was very nice. Thanks. Appreciate it.